it were placed at the center of our solar system, its immense size would extend all the way to the orbit of Jupiter. Eventually, Betelgeuse is expected to collapse in a powerful supernova explosion, an event that could result in the formation of either a neutron star or a black hole. The excitement surrounding the star stems from the fact that it is located approximately 650 light-years from Earth, close enough for us to observe such a rare cosmic phenomenon in real time. When the star finally explodes, it will release a stunning display of light. The first signs will be a wave of neutrinos sweeping across Earth, detectable by sensitive observatories. Shortly after, high-energy photons will emerge from the expanding debris, causing Betelgeuse to brighten dramatically, potentially becoming up to 100,000 times more luminous than usual. Depending on the intensity of the explosion, this blazing, celestial object could rival the full moon in brightness, possibly even becoming visible during the day and casting shadows at night. The phenomenon will last long enough to allow astronomers to collect unprecedented data and potentially make groundbreaking discoveries. While the idea of a nearby supernova might evoke anxiety due to historical interpretations of such events as omens, we can take comfort in knowing that we are far enough from Betelgeuse to avoid any harmful effects. To fully grasp Betelgeuse's recent changes, we must revisit the unusual behavior observed in late 2019. During this time, the red supergiant began dimming noticeably, a phenomenon visible even without a telescope. Observations using the Very Large Telescope revealed that, while the star appeared mostly symmetrical in optical images, its outer photospheric layer showed signs of significant disruption. The photosphere, where the star emits visible light, appeared to be expanding at a steady rate of 8 kilometers per second throughout most of the year. This outward expansion continued until mid-November 2019, at which point the star's material outflow began to decline. Around this time, astronomers captured new images showing two unexpected developments: a darkened region in the star's southern hemisphere and a drop in surface temperature of about 80 Kelvin. Between January 27 and February 13, 2020, Betelgeuse reached its lowest recorded brightness in modern times. Following this dramatic dimming, the star gradually returned to its normal brightness over the following months. This led scientists to ask what exactly had happened. The evidence pointed to an unprecedented surface mass ejection, SME, a phenomenon comparable to coronal mass ejections, CMEs, observed on our Sun. Imagine a massive stellar eruption, in which material from the star's interior violently breaks through the surface, causing intense shock waves. As the expelled gas cooled, it formed molecules and dust that partially obscured the star's light, creating the dimming effect seen from Earth. In Betelgeuse's case, the expelled mass was staggering, estimated to be 400 billion times greater than the material ejected in typical solar CMEs. This amount exceeded multiple times the mass of the Moon and traveled at astonishing velocities. This event marked the first time astronomers had directly observed such a large-scale SME. Using the Hubble Space Telescope, they were able to watch in real time as the star's surface changed, offering rare insights into the death throes of a massive star. The ejection had a profound impact on Betelgeuse, causing it to lose a substantial amount of mass in a single event. It appeared as though the star had violently shed a portion of its outer layers and was now slowly recovering. In the aftermath, the star's usual pulsation rhythm shifted. Previously, it exhibited a periodic brightness variation every 400 days. After the SME, this pulsation period changed to every 200 days. As a semi-regular variable star, Betelgeuse typically experiences 2 cycles of brightness changes caused by fluctuations in size and temperature. The shorter fundamental pulsation cycle lasts about 400 days, while the second cycle, whose cause remains uncertain, spans approximately 5.6 years. To better understand the changes, scientists used computer models, which suggested that an exceptionally hot gas bubble had formed within the star. This turbulent bubble, driven by convection similar to boiling soup, rose to the surface, triggering the massive ejection of material and disturbing the star's regular pulsation. The star's surface continued expanding while its inner layers contracted, leading to the new 200-day cycle. Astronomers predict that Betelgeuse's normal rhythm will gradually return over the next 5 to 10 years. As for when the long-awaited supernova might occur, estimates vary widely. Astronomers believe that it could happen any time within the next 10,000 to 100,000 years. Based on its color, brightness, size, and estimated age, Betelgeuse is currently fusing helium into carbon in its core, a necessary stage before advancing to oxygen, silicon, and ultimately iron. Once iron accumulates in the core, the star will collapse under its own gravity, resulting in a spectacular supernova. However, because Betelgeuse is 650 light-years away, even if the explosion occurred today, we wouldn't see it for another 650 years due to the time it takes for light to reach us. It's therefore unlikely that this event will occur within our lifetime. One unique feature of Betelgeuse is that we can directly observe its surface, an uncommon trait among stars. This makes it a valuable object for studying how massive stars evolve and die, especially during rare phenomena like mass ejections. In another startling astronomical discovery, scientists recently observed a star devouring one of its own planets, located about 12,000 light-years away in the constellation Aquila. This unprecedented observation adds yet another layer to our growing understanding of stellar evolution. Betelgeuse, with its distinctive name and prominent place in the sky, has fascinated humanity for centuries. Its importance extends beyond astronomy, leaving a lasting mark on mythology and popular culture. The star's name originates from Arabic, possibly meaning the armpit of the giant, though interpretations also suggest it could refer to a hand or shoulder. Across various cultures, Betelgeuse has been symbolically associated with different anatomical parts or animals. In ancient Japan, it symbolized a severed limb, while in Brazilian lore, it was seen as a turtle's leg or a jaguar's hind leg. In Sanskrit, Betelgeuse is called the Moist One, connected to the Ardra lunar mansion and the fierce storm god Rudra. Macedonian traditions linked it to agriculture and domesticated animals, while in regions like North Baffin Island and the Melville Peninsula, its rising signaled the arrival of spring. As the star on Orion's right shoulder and one of the brightest in the sky, now the seventh brightest, it continues to captivate artists, writers, filmmakers, and scientists alike. Betelgeuse's evolving behavior and potential to explode in a supernova remind us how dynamic and awe-inspiring the universe truly is. What do you think about the star's recent changes and its eventual fate? Share your thoughts. And if you found this fascinating, don't forget to like, share, and subscribe to Beyond Discovery. See you in the next installment.